we're going to review equations today, and we're not going to do a lot. You will have a little bit of time to work in class. We start with some basic examples working with linear equations. I begin by distributing what? When I distribute negative 5, I get negative 5x plus 5 equal 3x plus 2. Negative 3x plus 5 is 3x plus 2. Subtract my 3x, negative 6x plus 5 is equal to 2. Negative 6x is negative 3. X is 1/2. Nice thing is, if I want to verify my answer, what do? Just plug it in. What do you need, bud? Sorry. You can stay in here as long as you want, but I don't see it anywhere, sorry. Okay, letter B has a fraction, which I know freaks some people out, but we'll learn to deal with it. 3 over 2x is equal to 27. How do I get rid of that 3/2? Times by 2/3, the reciprocal. Very good. So I get x is, and you can take 27 times 2 divided by 3, or 27 divided by 3 times 2. Either way, you'll come out with the same answer. 27 divided by 3 is 9, times 2 is 18. And then you see an example C, and you're like, well, shoot, it's got more fractions. I can make this very simple by getting rid of the fractions. How could you get rid of the fractions? Why 15? Yep, it's the least common multiple or the greatest common factor. I'm sorry, or the greatest common denominator. Yeah, great. Wow, now we're really mixing things up. It's the common denominator or the least common multiple. All right, so 15 divided by 3 is 5, times 4 is 20. So we have 20g. 15 times 12, well, 15 times 6 is 90, and then doubled would be 180. So 180. Divided by 3 is 5, times 4 is 15 times 4 is 60, divided by 3 is 20. And 15 times 12 is 180. I didn't know that, so I did 15 times 6, which is 90, and I doubled it to get 180. 15 divided by 5 is 3, times 2 is 6. Great, so now I'm going to subtract that 6g over. I get 14g is equal to negative 180 when I subtract the 180 over. Divide by 14, and I get g is negative 90 over 7. How about the last example of the linear problems? I'm going to multiply by 30. Are you okay with 30? So what's 30 divided by 5? So 6 is then what you distribute through. We get 18x plus 12. 30 divided by 3 times 1. 30 divided by 2 times 5. 75. So all the fractions are gone. The denominators are gone. (18x plus 2 is 75x plus 10. Negative 57x is 8. Some people come up with negative 8 over 57, and they feel like they did something incorrectly. Because if you're doing equations, then the answer should always be, say, 2, or negative 3, or 4, or, want integers. We're not always going to come up with integers, folks. We're big kids now. So, all right. Okay. Let's go to one of the most powerful and useful properties in mathematics, the zero product property. And it says if A times B is equal to 0, then we know something is true. Then either A or B is equal to 0. Let's try a different product property. Let's try the for product property, okay? Let's say A times B is 4. So what do we know about A or B then? I mean, it's rather ridiculous, isn't it? I mean, for example, let's suppose that A was 1/3, okay? Then B would be 12, wouldn't it? Or suppose that B was 7/3. Then, A would be what? 12/7? Like, you don't know anything about either one. If A is a certain value, then B could be a different value. You don't know anything. The for product, there's a reason why there's not a for product property. There's nothing helpful about it. It's got to be 0. I'll make my point here in a second. Product. Product means you write it as multiplication, which is what you do when you factor something. Factors are products. So, x minus 5 times x plus 3. I have a product of two terms. This is term A, this is term B. Either A or B must be 0. So x minus 5 is 0, so x is 5, or x plus 3 is 0. X is negative 3. Easy, right? So why do I get this? Some people get to the test or other times throughout the year, and they invoke the 5 product property. They're like, okay, let's do it. Factor it. So x is 5, or 6x minus 1 is 5. So x is 7/6. Now, the fact is that all of you know that that's not correct, but many of you get tempted to do that. In fact, it always happens where at least one person does it on the test coming up. Okay? There is no 5 product property. But there is a 0 product property. There is a 0 product property. Thank goodness. Six x and x. 5 and 1. Plus and minus. That's how that factors. If you like to do the AC method, go ahead and do the AC method. So what are our solutions? X is 1 and negative 5/6. Notice I have 2 solutions, and the degree of my original polynomial is 2. Most of the time, that's what we should see. Come up with that number of solutions. Let me flip it over. Okay. We're going to go through example 3 today. Letter C, we have 3rd degree, so how many solutions should we hopefully see? What do I do to start this one? We start with the greatest common factor, and then solutions. Yep. Letter D, I'll often get somebody who invokes the -2 product property. So they'll factor out an x. And then, even though it doesn't factor, they'll still factor it. Let's see. I don't know. They get lost here, so we'll go like that. So we've got 0. No, it's got to be equal to 2. So -2, -1, and if I subtract 1, -3. So looks like some pretty good math, right? But it's right. Like out of 3 points, I really want to give you 0 on that. I maybe could give you 1, but because I don't know. For trying hard, I don't know. So I'm going to use the 0 product property. And I get why people did, the example I showed, because they don't know what to do in this factoring process. What factoring method do I use? Grouping. And I don't like to put a parenthesis down in front of a subtraction sign, so I'll make it plus a negative. Factor out the x squared, x minus 2. Factor out a -1, x minus 2. And x squared minus 1. Plus or minus 1 and 2. So, easy peasy, right? We've all done this before. You will get a strong review of that as well in Chapter 3. Right now, let's move to something that might not be as familiar to you. 2 examples of completing the square. You don't hate this. You hate like world hunger or racism or oppression. You may loathe it. You loathe it. So I would like to challenge you into thinking that it's really not that bad as long as we just understand the basics of what it means to be a perfect square. So those are all perfect squares. Why is x squared minus 14x plus 49 a perfect square? Because it factors to a square of a binomial. So now somebody was going to, I think Natalie, you were going to say that if you take square. And let's see if that holds up. She said take the middle term, divide it by 2, and then square it. Take the middle term, divide it by 2, and square it. Piece of cake, upside down. So let's do that here. We know that 5 is not a perfect square, so let's move it over to the right-hand side, and let's make room for a perfect square. What is the perfect square that we would add in? 1. We take the middle term, we divide it by 2 to get 1, and 1 squared is 1. So if I added 1 there, I add 1 to that side in order to maintain balance in my equation. This factors to a perfect square. What perfect square? How do I get rid of the square root? Or of the square? I can take the square root. Now, how many solutions should I have in this problem? 2. So I list x minus 1 is equal to not just the root of 6, but plus or minus the root of 6. That way I'll come up with 2 solutions. In order to solve for x, I add 1 plus or minus the root of 6. So we have 1 plus the root of 6 is one solution, and 1 minus the root of 6 is a secondary solution. That's your final answer. Not too bad. What makes the second one more challenging? Yeah, so let's get rid of that 2. Let's divide everything through by 2. It's easy to do that because it's equal to 0. You understand that? Right. If it wasn't 0 over there, it wouldn't work out so nice, which is what happened second semester. We don't have a 0 over there. So we get x squared plus x is equal to then positive 1/2. What do I add to complete the square? Somebody save me. It would be 1/4. 1 divided by 2 is a half. A half squared, or a half times a half, is a 4. So this factors 2. X Can I take the root of 3? Can I take the root of 4? So when you subtract the half, you get negative 1/2 plus or minus the root of 3 over 2. Or you could write that, since they have common denominators, as negative 1 plus or minus the root of 3 all over 2. And it doesn't matter to me which one you write. Either one is sufficient. But that's that. What do you think? All right. Here you go. Your assignment. Okay. 18 minutes of instruction. Not too bad. 1.5, page 57. Not real long, but please stay on top of your homework. It's good to get a lot of review this time of year. As the year goes on, sometimes the assignments get shorter, but it's newer material. So right now we're in the middle of review. Hopefully you can handle the practice, and we need it, so we're going to take advantage of that.